Hello everyone, welcome back to the uh, 5-day workshop on machine learning and its applications in IoT, wireless sensor networks and images. So I hope all of you had a wonderful morning session. And in this session, we have Dr. Vijay Bhaskar Semwal from Maulana Azad National Institute of Technology, Bhopal. Just to give you a brief introduction, sir, this is a 5-day workshop on machine learning and application on images, machine learning and applications on images, IoT and wireless sensor networks. This workshop is being curated by IIT Lucknow in collaboration with University of Essex. The workshop is funded by GCRF at the rate Essex. So we are hosting in total 10 sessions in the duration of 5 days. This is the second session of the day. And to introduce Dr. Vijay Bhaskar Semwal, dear candidates, Dr. Vijay Bhaskar Semwal is Assistant Professor in Department of Computer Science and Engineering in Manit, Bhopal. Dr. Semwal you can visit his profile and you can see the dynamic resume he has. He has several publications. He has extensively worked in the area of artificial intelligence, robot planning, and bipedal locomotions. So I'll hand over the session to Dr. Semwal. He may start his session, and you please, all of you, ensure that your mic is mute during the session. And at the end of the session, we can have 20 minutes or so, sir, for question and query resolution. Okay. Over to you, sir.
Okay, thank you. Thank you for a nice introduction. So what I will do, the theme of workshop is machine learning applications in IoT and image processing and as a sensor. So what I will do, I will give brief about machine learning. So it is not like very basics, little bit we'll talk about data dimension also and how you can apply different kind of kernel function. Little bit application kind of things also I will tell because but basically, I will give all things which is required for to start machine learning as a beginners. Okay. So without wasting time, I'm directly going on some layman definition which you can find on Wikipedia also. Machine learning is what and how it is different from traditional learning and now deep learning is evolves. Okay. So simply machine. So if I'm talking about machine is a computer. So okay, robot is also machine. So machine is a branch of AI. So generally, our target to machine should learn. Okay, how machine will learn? If you see traditional algorithm kind of approach in which we have algo, so we have input, we have algo, and we are getting sequential output, executed output. In this case, what is happening? We are learning through data. Machine is learning through data, so data is required. So that's why I will discuss about data dimensionality also. So it's a branch of computer science only, AI. So in this case, we have input data and we are trying to learn the pattern whether we are predicting something or whether we are classification. So as a human expert, what is our role? Our role is that our decision should be very robust or very correct. We don't want we can take everything because we don't have knowledge of entire universe. So we have very limited knowledge. So data is like the entire universe. You require more and more data to learn everything. So like human brain used to learn different capability, but many times we used to speak about domain expertise. That means we are expert in particular domain, we can take better decision. So that means I have available that particular data. I'm not explore all sort of data. So if you have very good data, in this case, you will suffer with some problems like overfitting, underfitting. Then I will talk about generalization of model, how you can make generalized machine learning because data is okay. The moment I will talk about big data or big data, it is not volume of data, it is variety of data also, where we are taking different sort of data. Okay, so that is very layman diagrams, traditional programming like quick sort algo. So we have given data and program, and we are getting some output either sorted order, reverse sorted order. In ML or machine learning, what we are doing, we have data. Okay, which is main correct, and second thing is output here is label data. Label data in the sense if I have two columns like I need to detect whether person is healthy and unhealthy. So those it is binary classification like yes, no, healthy and healthy. In this case, suppose I am taking temperature as well as blood pressure, two features. BP and temperature, and based on this one I'm deciding whether person is healthy or unhealthy. In this case I need only expertise like doctor can decide. So you have BP, you have temperature. If temperature is more than 100 degree or BP is also more than 100, then I will assume that person is unhealthy, otherwise it is healthy. So this is binary classification, there is decision bound. So all machine learning algo has only objective to find the better decision boundary. That is only what we expect from human expert also. You can see that you are visiting to doctor, the new doctor, you are visiting the experienced doctor, the things that because he can take better decision with the limited number of parameter, because number of parameter if you are taking input, so model will become complex also. So just understand data is your features, output is your class level like healthy and unhealthy, input you are giving BP and temperature. Based on this one you are deciding your decision boundary. The target is decision boundary. So machine learning is learn from past, predict the future. So nothing else. So before learning, as we have to learn walking also. So I was in the gait analysis. In this case, how human baby is learning. So first they are continuously interacting with the environments. Okay, we have sensory organs like IoT. You have sensors, vision sensors. We have pressure sensor, temperature. Similarly, we have sensors like our eyes, our nose, our touch skin, palm, all these things which are giving us inputs. Okay, sensory organ is giving input, then it is going to process in our brain. Okay, and many times we are storing some information also in brain, and then we are predicting in future. Okay, so what is happening? First we are acquiring information and then we are testing. So what we are doing, I will first we have to learn the behavior. So this is training part and testing part, where we will test the model. Okay, so training, generally we have data, we used to divide into training and testing, then cross validation concept will come in the picture, or K4 validation, and then data has many time problem is like imbalanced data also, where we are lacking with the data, like suppose healthy and unhealthy. Healthy samples we have 19 sample, and healthy only 10 sample. So model will learn bias, because you are not exposed with the most of the data which is for unhealthy subject, because it is very limited data. So these kind of problem will address later on what is this imbalanced data. But here you just need to understand, before testing you need to train. So always once we have data, you will divide into training and testing parts. Most of the portion we used to divide with the 70-30 ratio. As such, there is no logic 60-40 ratio you can divide. Otherwise you can perform cross validation, or the best recently which we are using deep learning also, we are randomly shuffling all the data. Randomly shuffle the data, though it is supervised learning. When you are knowing the class levels, whether it is healthy sample and unhealthy, that is supervised learning. Okay, so training and testing part is there, that is what. So model is learning. So model could be your mathematical model. Either you are learning some equation of polynomial, either you are learning y equal to mx plus c, equation of line. So this is what model is there. So this model will help you to predict or classify. Okay, so in case of linear regression you will predict something. In case of classification you will do whether it is class A or B, whether it is human being or animal, like this classification. So, and when you are acquiring data, the important thing is that data should be structured, because in entire world data is scattered in unstructured format. Okay, so it is also very important which kind of data you have. You require balanced data also. Unbalanced data many times will lead for wrong hypothesis. Again, I have introduced the term hypothesis. Hypothesis is nothing but it is SAM model which I am talking, mathematical models, equation of line or polynomial, whatever. So you can see that example, basic layman example is there, apple is there, but apple has two different colors and banana has two different. But how you rename? Because we know that this is apple first two and second, because we have acquired through our sensory organ eyes, we have acquired image, and already some pre-stored image in our brain we have matched. It is very similar to the apple, so we have identified. But machine cannot do without data. So data structure is always, data structure is in sense structured data I'm talking about. That means data should be in valid form. It should carry some information. It is not that I'm carrying redundant information. Redundant information will lead for wrong hypothesis many times. Okay, so data is mainly dealing with the traditional machine learning algo. So like suppose movie rating, you are looking for movie. So which movies I should watch? 4 movies there in the market. They have released 4 movies particular Friday, and I'm not aware of anything. So how will decide that which movie I should watch? So either I will see that what is the rating of other people has given, and based on this one we'll do. So data could be your image, your video, your numerical data, your text data, any sort of thing. So that is type of data. Either sensory organs, like this is kinect sensor. Kinect sensor is as vision as well as depth sensors, which is actually acquiring information of joints. So I've used this for human walking pattern detection as well as recognition. This kinect sensors, very sophisticated sensor were developed by Microsoft. You can have these different sort of sensor, pressure sensor, touch sensor, and all. So data could be any form. Now I'm coming on directly supervised learning, and I will take only 2 or 3 minutes to explain this one, and then directly we'll go to linearly and non-linearly separable data. Okay, so supervised learning, the moment I'm talking supervised learning, that means each and every data is labeled. Labeled in the sense, I know that if BP is 90, temperature is 100, so person is healthy. BP is 110 or temperature is also 102, so I will assume that this is analysis. So that means each sample is in the sense number of rows I am talking about, number of column I will refer as features, data. So data could be n dimension data. So it depends on how many features you have. Okay, so in this case what I've done, level 1, level 3, level 4, level 5. It is not carrying any information what this level. So anyway, if I will try to train my model with such raw data, okay, such unlabeled data, because maybe that particular person is not expert of these fruits to identify fruits, so they have just given level 1, level 3, level 4, or level 5. It is not carrying any information much. Better I can give red apple, green apple, yellow banana, and green banana. That is quite informative and concise also. So just you understand, we are started providing label, but label should be correct, good label. If you want good decision boundary, good predictor, you require labeling also. So that's why machine learning is not all about to apply some particular algo. We have to do a lot of things on data processing also, pre-processing. That's why it's carrying very important. We have to avoid imbalanced data also. We have to provide correct label also. Okay, so that's why domain expertise also required. So after once we have labeled the data, you have predicted the models. Model could be your KNN, CNN, or any model. Okay, so or model could be mathematical model, some equations, or based on image I'm trying to identify color or texture, anything. So once a model is predicted, so this is training phase. You have data, you are predicting. Now what happening in testing phase? You have this yellow color apple, and I have trained with red and green color apple. So what I'm supposing, human being easily identify this is apple, and my algo should have this capability. It should identify this is apple based on shape and texture. Those colors might be different, but it should identify it as apple. But what will happen, because we have very limited data and we have not given the exposure, if we have not given proper labeling of data, in this case maybe I will not able to identify this is yellow color apple. So what is happening here, my model got underfitting because I am not given sufficient information, sufficient number of parameters. Okay, it will give more number of parameters. In this case what will happen, overfitting. So the moment you have trained with the red and green color apple and you are identifying this yellow, if your model is able to identify this as apple, so your model is generalized, very generalized. That means it has capability to explore the data which is not trained before. Okay, so based on certain features it is identifying. So we have generalization capability. That what my objective, my decision boundary, my prediction should be so correct, or at least 80-90% it should be correct. Okay, supervised predicting new data. Every machine learning algo is learning from the new data. Okay, now what I've done, same thing is there, same supervised learning, same labeling I'm providing, only I change the label. Now I've given the label apple, apple, banana, banana. So what I did, I've done a little bit like clustering kind of things. I made a group of apple and banana based on their shape or texture. Okay. So what will happen here? I will have better capabilities. So classification is finite set of level. So what is the limitation with this supervised learning? When data is very limited, then you can easily label all sort of data. It is not possible to label every sort of data of universe. So that's why unsupervised learning kind of model evolved, and that are more close to human learning, supervised learning. It is not that everything is everything you have seen in your childhood only. That's why you are learning. No, it's a learning process, and learning process is continuous. You learn throughout life. So that's why, because you have not get exposure of entire universe in a time. So you require time to learn all the things. That's why we are moving for unsupervised learning. Okay. So just definition, very famous definition given by Thomas Mitchell in 1998, and that is very popular also. What is machine learning? You can find Tom Mitchell book. So they have told that machine learning is the study of particular algo, because the parameter is performance. Okay, improve the performance at some task. My task is to identify or predict with experience. Experience here I'm talking about my data. So whatever data is there, if you are a new doctor, you will have very less set of data. If you are a experienced doctor, you have more data. So you have data, you have tasks to identify, classify, and iteratively you are learning, because if you have 10 years of practice, so you will have better capabilities because you have exposure of this one. So 3 parameters they have defined: performance, task, and this is, they told us machine learning is the study of algorithm, improve their performance at some task with experience, well-defined learning task. Then later on the generalization capability will come. So with a very limited set of data, my model should be able to learn, and it's at least it has performance around 80 or 90%. Then I'll think that my algo is working perfectly. Then you can refer also Murphy, Kevin Murphy and Christopher refer definition, because both are very renowned in this field. So you can go, I'm not going in the definition part. Let us understand what is decision boundary, and then go for linearly, non-linearly separable data. Then different algo will see that what is KNN, ANN. I mean, will not go in depth. Just I will tell what they have capabilities. So you see that you have 2 dots. One is yellow color dot, another is orange color dots. Okay. So we ask you to draw the decision boundaries. Draw the decision boundary here. Okay, so let me take annotation. Okay, so you can have this decision boundary. Okay, if you have this decision boundary, you can separate out both yellow dot and green dot perfectly. Okay, I will take another color. I can have. So I think. Okay, anyway, so what is happening in this case? I draw this decision boundary, okay? This red color. What is happening? It is perfectly making separate out your this orange color dot from yellow. So that is the perfect decision boundary. But in our algo, what is happening? You don't have any decision boundary. If you see this particular decision boundary, what is happening? This decision boundary is not perfectly separating out both the data. Okay, yellow and orange are somewhat misclassification happening. Suppose let us consider that if below of this decision boundary less than 0, suppose this is decision boundary greater than 0, I am considering the orange sample, or less than 0, I am considering the yellow sample. In this case, what is happening? This is 4 plus 5 misclassification here, and here if this is orange boundary, I have 4 misclassification. That means this boundary is not perfect, and that is quite obvious. Initially, we have lacking with the data or lacking with the experience. That's why we are facing this problem. Okay, so with time you will learn this decision boundary better. So my objective, I can make such a decision boundary which can separate out both the data with good performance. That means at least 90%. Here I'm achieving only 50% accuracy with this decision boundary. Okay, so let us see that how you can go for better decision boundary. So the algo is trying to learn. That means I'm giving more data, more experience, more iteration I'm learning. In first iteration I learned this one, second iteration I learned, that means I extracted more better features from there, more better pattern, and finally that is the perfect decision boundary which I was expecting to separate out both green and red dots. That was my objective, to draw the decision boundary. So if you see that this decision boundary, so it's like complex decision boundary with some polynomial, you can see like polynomial with the higher degrees. You see that like this, I think that this is 4 degree of polynomials. Okay, so the moment I'm going for out of line, if you cannot draw a line, then it is becoming non-linearly separable data. Okay, so directly I'm coming on what is linearly separable data and what is non-linearly separable data. So linear classification and non-linear. The example which I have shown you, that was example of non-linear classification data, and here I am trying to learn some polynomials, higher order of polynomials. Okay, if you can fit the line in particular dimension, and the more you see that now I will introduce the dimensionality also. So it is 2-dimension data. You have x-axis. Let us this is BP. This is BP and this is my temperature. Okay, this is my feature. Okay, these are my predictor. This is my healthy sample, and this is COVID positive negative sample. Negative samples in the sense unhealthy and healthy. Okay, so you have label. All data is labeled because you have provided the color to all labels. Okay, so based on BP and temperature, I'm able to provide the label, and I'm trying to learn the models which can perfectly classify this healthy sample with the unhealthy samples. That is only what machine learning try to do. So let us understand linearly separable data. So dimensionality also you have learned now. As previous is image was 2-dimension data where I considered temperature and BP, and the class level was also 2 levels, that was healthy and unhealthy. So class could be binary classification and multi-class classification problem you can have, like digit recognition, MINST data if you have heard. So it is you have to identify 0 to 9. That means 10 classes, different class. So you require data of 10 different classes. In this case, I require only healthy and unhealthy. So it is again binary class. Yes, no, 0, 1, all are example of binary classification label. Input is given X, and that should be some dimensionality because you will have matrix M cross N, and that we consider as M. If M is feature, so I will consider that M number of M is the dimensionality of my input data, and the class label is binary. So I'm talking about. And in case of linearly separable data, I'm expecting I should able to fit the line in the my data. Okay, like I will give example AND and OR gate, which is example of linearly separable data, and JOR gate is example of non-linearly separable data. And I can also draw here like this. Suppose we have plus, 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 and there is cross, cross. Here I can easily fit. The line here. Let us take different color. One line I'm able to fit. Okay, you can have infinite number of lines. It is your algo job, how good it can fit, and it is based on your experience. This hypothesis is moving. Hypothesis you can go for positive and negative side. So this is your decision boundary. All data which is falling on this one is satisfying equation of line y equal to mx plus c equal to 0. All data which is going here is greater than 0, the value of y, and all data falling in this region has value less than 0. So this is your decision boundary. The data which is coming, getting less value, they are positive plus sample, and this is cross sample. So here what is happening, I'm just drawing one line in 2D plane. In 2D plane, maximum I can go for, if you are talking about linearly separable data, I can go for 1D, one line I can draw. In 1D, I can draw only dot. Okay, so 1D, I will come on next, so I will not waste much time here. So equation of line, same thing I have written, equal to y equal to mx plus c. In case of neural network, what I am writing, Y equal to W transfer X plus B, where W is your weight matrix, B is your bias, and X is your input, and Y is your output. This is sigmoid function. Sigmoid is non-linear activation function. Okay. Then what I'm doing, if sample is greater than 0, then I'm considering it is +1 class, or less than 0, this is negative class. Okay. The same thing. So now you can see that easily you can draw the line. This is Y equal to mx plus c. Okay, you have two features, x1 and x2. So if you'll see that your slope has two features, x1 and x2, two-dimension data, because your input is two-dimension data. So you'll have weight matrix also. Bias is telling how far you are from origin. Okay, so bias you can refer like in artificial intelligence, it is some hint, because all sort of data we are not exposed. Many times we used to take the help of someone else. So you will tell that no, go in this direction. That means we have taken a little bit some bias. Okay, so we are shifting this line, so we can have multiple lines regarding. So this is linearly separable data, because we can easily draw this line. In 2D I can draw a line. In 1D I will have draw. In 3D I can draw a 2D plane. Okay. Now the question will come, the moment I will convert this 2D data into 1D, that means I will reduce the dimensity. What will happen? The data will project on one line, all red and black addition sign will draw on one line, and then you have to draw the dots. Okay, so this data will get skewed, and this data will become non-linearly separable data in 1D. In 2D it is linearly separable data. In 1D what will happen? It will squeeze this data in 1D. So all positive sample will come somewhere like positive, 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 and then black sample also there. Black is coming like this. Okay, like this dots. So if you have to draw the decision boundary, what will happen? You have to draw like this decision boundary. Okay, so now it becomes non-linearly separable data in 1D. Though it was linearly separable data in 2D, but reducing dimensity from 2D to 1D, what is happening? It is squeezing, and same line is getting squeezing, so it is becoming zigzag kind of lines. That is what. So it is possible that if data is non-linearly separable in data 2D, so we can go in higher dimension and we can make it linearly separable data. So I hope that this concept is clear. So let us move ahead. Oh, sorry, by mistake I pressed something. I think I am audible to everyone. Yeah. So now, if the moment I'm talking about model, it is hypothesis only class, and I will not go in this case. Now I'm going for a little bit non-linearly separable data. Non-linearly separable data. So in this case, what is happening? Same data, same two-dimension data, but samples, these are data samples, Ram, Syam, Sita, Geeta, and this is BP and temperature. So I will label that these are positive samples and this is COVID negative samples. Okay. So what is happening here? You cannot draw one line in 2D. In 2D, you cannot draw a line. You require some decision boundary like this, so that you can separate out. So all data which is falling out of this line is black, and coming inside this is red. Then you can draw decision. That means you cannot draw one line which can separate out all the data. It's red and blue separate. So that's why it is non-linearly separable data. So one thing that you can project this data into higher dimension T. Okay, so non-linearly separable data is the. So let us understand what is one dimension data and how we'll make this is linearly separable. So one dimension data is, you can see that in one dimension I plotted all. So like this is blue dots and this is orange color positive sign. So if you require which kind of decision boundary you can have, this one. But 1D I cannot draw this boundary. 1D I can put either dot this side, either dot this side. So either these four will misclassify or either this 4 will misclassify. Okay, so in 1D I can maximum draw the dot, so you can project this data in 2D to make linearly separable. But in 1D this is non-linearly separable data, because you cannot draw any decision boundary which dot which can separate out both samples, both blue color with the red addition. Okay, so that is not possible. That's why what I'm expecting either I will draw here one dots which can separate out this data with this one data. What is happening? These four are going to misclassify. Okay, if I will place dot here, in this case, I'm going to misclassify these four. If I will place dot here, in this case, I'm getting these two are misclassification. So that means it is non-linearly separable data. You require some decision boundary which is non-linearly. So same data I will project into 2D, and then later on I will ask one question in which you have to guess which kind of function I will apply to sort out this problem. So now what I have done, same data, it was initially only x-axis. Now I have given the y-axis, and it is just dot product of this one. I'm taking x square. So initially, suppose x is there -4, -3, -2, 1, 0, 1, 2, 3, 4, like this. So I've given value, and I've considered x and x square in our two feature. So x-axis you have x, y-axis you have x square. So earlier what was 0, it is becoming 0. -1 will become +1, and +1 will become +1. My -2 will become 4. So it is going positive sign. My -3 will become 9, 16, 15, 20. Now you can easily draw the line. The data which was non-linearly separable in one day, now it becomes linearly separable data. So here which function you have applied? Kernel function, square function. Okay, you have introduced one new feature. Though it is linear combination of x square, you can have if it is vector, because all dot is vectors, because they have direction as well as, okay, they have direction with respect to origin, and they have xy coordinate. Okay, so these are the dots. If I'm referring, these are vectors. Okay, so this is dot product x square. You can write x transpose dot x, correct? So we will not go in depth. So now you can take this exercise at home. How do you apply for something for JOR gate? JOR gate is also binary classification. You have either 0, 0 and 1, 1, you will get 0 output, and 0, 1, 1, 0, you will get 1 output. So even number of one case is here which you can deal. Okay. Now I'm giving you just some samples. Left hand side it is 1D data, and right hand side already I drawn in MATLAB, Python, 2D data. Same data is there. So you just need to guess which function we have applied by which this non-linearly separable data is converted into linearly separable data. So first example already I taken x square, and the value become like square curves, and then we can easily draw this line. Second case, what is happening minus, you can see there. So this is highly non-linear data, because after each this blue square I'm getting orange dot. So you require how many degree of polynomials to make separate out? You can see that maybe 9 or 10 degree of polynomials. You require this kind of non-linearly separable data. Highly non-linearly separable data in 1D. Almost you require 1, 2, 3, 4, 5, maybe 10 humps is there. So 10 degree of data. So the moment I converted into another things, so what I've done here, any guess? If you want to see, you can write in chat box so I can see. Otherwise, I will tell the answer. What I'm doing here, I'm just making even and odd difference. Even number I'm giving +1, odd number I'm giving -1. The moment minus, suppose this is 9, -9, -8, -7. So all positive samples, which I have mapped with the +1, it is even number, and all negative -1 mapped with the odd number. So that what I have done. And so let us see function also. First one I've used x square, and second one I use modulus 2. If it is remainder is coming 0, that means even number. So I'm making it +1, and in case of negative I'm making it, in case of odd number I'm making it -1. So that is, you can draw any, that is what kernel function is doing. You have learned in support vector machine kernel function. Kernel function is job is there. You have a square, quadratic, cubic kernel functions. You have radial basis function. So many other kind of kernel function which you learn in depth there. So that I'm not supposed to discuss here. Okay. So already enough we have discussed about classification and prediction. Now let us go in classification and prediction. Like simple example is there. So income and saving, and based on this I need to grant you whether I will provide you loan or not, or banking. Bank has to decide based on your income and how much you are saving. So they will give you loan or not. Based on this one, they are giving you two levels, whether you are low risk area, high risk. If you are in high risk, they will not provide you loan. If you are in low risk, they will provide. So when you have low risk, when you have good income as well as your saving is good. Okay, when you have very less income and saving is zero, in this case, obviously they will not give you loan. Income is more, but saving is very less. Then still you are, like your income is more in this case, but saving is very less, still you are in high risk area. Your income is, saving is more, but income is less, then they will not consider. We want reasonable number of income. So here what is happening, you cannot draw decision boundary like you are drawn two lines. Okay, so it's again becoming non-linearly data. So you require two neurons to separate out this one. So this is what classification is there. Okay, so classification application where I can apply. So we can apply in face recognition, character recognition, character, whether it is numerical character, alphanumerical character, or digit recognition. MINST, very famous data, almost 60,000 image of different font and styles are there. Okay, spam detection, whether your mail is genuine or this one binary classification. Medical diagnosis, whether you are suffering with COVID sample or you are not, based on certain features, symptoms of the biometrics, very popularly using for recognition, authentication using and different kind of biometrics possible. Your behavior biometrics is there, a physical biometrics, psychological kind of things also there. So supervised learning already discussed enough. 1D data is already discussed. The data is non-linearly separable. The moment we are projecting into 2D, it is becoming linearly separable data. Okay, and either this is decision boundary, so I'm not going this one, already I discussed this one. Now let us a little bit move on unsupervised data, in which data is not labeled. Okay, so clustering kind of approach will be there. Now what is happening here? In the left figure, if you'll see that I'm not provided any sort of color to any. Those you can see that they have similarity, so that's why they are forming one cluster. Okay, one cluster, second cluster, third is by appearance also you can see that there is three cluster. Okay, so you have two dimensional data X and Y, but there is no red, green and blue kind of clear distinction. That means we have not provided the label, whether it is unhealthy, healthy or this one. Okay, so this is the case of unsupervised label, where we are not providing class label. We have data samples, we have features, but label we have not labeled data. So based on similarities, whether we'll calculate the distance, how far I am close to which station. Suppose you have to identify whether it is Indian or Chinese. So you can go for geographical location also. You see that how far I am from Beijing or Delhi. The person who is near to Delhi, it is Indian. The person who is near to Beijing, it is Chinese. So similarity, different similarity matrix are there. Equivalent distance you can calculate. K and algo, K mean algo, all sort of things, clustering algo is also there, which are somewhere they are using distance measure to form the cluster. So just you understand here, based on similar feature, we are trying to group the peoples together. So now, so the question, so far I have discussed about classification, I have not discussed about prediction. After now label, initially I given apple and banana. Now what is happening when you will have something like minus 0.4 times real numbers, 10.0, 3.245. In this case, you are getting real number as a label, so you will go for regression. You have learned about linear regression and logistic regression. Logistic regression is very similar to sigmoid activation function, which is again probability based function. All value you are mapping with between 0 to 1. So when label is real value, then you have to go for prediction or regression. Okay. So a little bit you understand about regression model also. So you have to decide the car price with time, how it is changing. And here we have given X mileage and Y is price. If mileage is good, so price should be greater or less. We have to find the pattern. So what this image is telling, if mileage is more, price is less, and that is true. If mileage is less, price is more. So I have kept one hypothesis. You can also draw one hypothesis, artificial library. This is also your hypothesis. Okay. Only thing that here you have one class data. Okay. So you see that how far I am from this data. That is only we know the error or okay. So you require bias. Bias is that how far it is from origin. This is my bias because my data is distributed here. What I can do, either I can make origin here by subtracting this bias distance. So the equation is y equal to mx plus c. This is mx plus c. So you can make c 0 when your coordinate system will be here. The origin will. So you will subtract all data sample by minus b. So this term will become 0 and equation will become y equal to mx. Okay. So I have drawn one hypothesis and they given. You can have your own hypothesis. No problem. Okay, so mileage and price. So I've kept this one, and this is error. Okay, and all distribution are Gaussian distribution. The price should be vary within particular region. Okay, I'm expecting that it should be in Gaussian region, and the error level should come within this region. This is your variance. Okay, variance stuff, which shortly I will discuss about variance. How data is varying about mean, your mean value, that is referred by variance. So in this case, simple equation of line I fitted for prediction. You can go for higher order of polynomial. You can fit like this also data, where you have 0 training error. Because these are the training samples, you have 0 error because almost every data is falling online. And this is a little bit complex decision boundary of 2 or 3 degree of polynomial. First one is very basic model equation of line, and but there is error. Data is little bit far. This is your error. Okay. So in this case, what is happening in previous model will suffer with the underfitting, and secondary model where I'm going for higher order of polynomial. So what will happen? I will have more variance. Okay. So if you have like higher order of polynomials, so variance is somewhat, what is my objective? Maybe it is my predictive model or it is my design model. I want that this distance should become 0. Model should overlap with this one, but ideally you will not find, and that is term is error. Error is which I am telling, these are the errors. Okay, so generally error is also required to make the generalization capability, because I don't want to suffer my model with the overfitting. My objective should be, it should not be underfit, it should not be overfit, it should be balanced. So bias variance trade-off very soon I will discuss. So this error I'm trying to minimize. Okay. This is my training model and this is my testing model, and the error between both should be very less. And the variance you can understand like this. Like this is my model. This is my mean value. That is 0 mean. Okay. Gaussian. Okay. Mu value is there. So the how data is spread around your mean. Okay. So maybe mean height is average Indian height is 5.9 feet. So how data is average mean more than 0.9 feet. And more less than 5.9 feet. Okay, so you can well justify. You will find very less tall people so far in India, and if you will see the China demography, the model will change different. Okay, so they have fitted very basic line, equation of line. I can fit the curve also. So where you can apply regression, where you have to do prediction, whether economics, you have to predict the share markets, stock markets, or Bitcoin and anything's price, how it is going up and down. So you have some real kind of value, finance sector. Epidemiology, most of the people are working in COVID-19. They are predicting when the Indian COVID patient data will reach to 5,000 or 5 lakh or 20 lakhs. They are predicted with basic model only. Okay, you can use some statistical model also. So you can, the moment you will involve more number of parameter, you will have better prediction, but number of parameter increasing will lead for overfitting also. Okay, so overfitting, the reason of overfitting may be like you have this model. Okay, so it is perfectly, maybe it is perfectly matching to all data sample, but what will happen the moment I will draw another hypothesis over this one, so it will have high variance. Both model will have difference. So it will lead for high variance. If it is equation of line, you draw more lines, different lines, they have very less variance. So variance, more variance will lead for overfitting. You can go for car and plane navigation system, where also we have to many time predict when I will reach to, suppose I'm living from Singapore to India, how much time it will take, which TGT I'm following, how much delay I can face. Okay, these are all sort of things you can easily do through this one. Temperatures, weather forecasting, even cyclone is coming based on previous history they are going. So all sort of prediction you can do where prediction is required. So classification, ranking also. Okay, so you can provide the rank level supervised learning data, ranking. So ranking is required when you have to see something is good. You are going to watch movie. So which movie I will watch, that time you will see rating. So you give the rating between 1 to 4. Based on this data also you will see that which has good, better, average rating, and this way I can go. Okay, so even Google query search engine, they are using this rating. How many people has visited? That is page ranking algo. You can learn about page ranking algo Google. So they are giving the mostly explore or mostly searches page link will at the top. So that is based on ranking. Again, Netflix, already you have seen iTunes, flight search, which search is popular, which train is popular, which bus is popular, because most of the people are searching. So directly dig on the unsupervised learning and then understand overfitting, underfitting. And so now you have 3 apples. I'm not providing any labels, only I am seeing that similarity. So all red, this green and little bit red and yellow is coming in same cluster because they have similar features, and banana will come in one cluster. So based on similarity we'll decide. So you have learn cluster, group within the level, customer segmentation, image compression, biometrics, and all sort of things coming in unsupervised learning applications. Okay, then little bit third kind of learning is you have for semi-supervised learning also, but I'm not going for semi-supervising, but you can see that reinforcement learning. And more depth, I'm not going for reinforcement learning. It's like as a you don't have any data, but you are learning itself from the environment when you are interacting. If your behavior is good, you are getting appreciation. If your learning is not good, you are getting some punishment or reward. So you see that first what I've done, I followed the step. First I went left, right, straight, left, and I reached my target. So they have given good. You have done your job. But when I follow another TJT, left, straight, left, right, in terms of robot, you can understand. So it is not reaching to goal and it is moving very far to goal. So what I will do, I will tell, no, your learning is very wrong. You have not identified your target perfectly. Okay, so it could be in terms of good or bad. It could be in terms of quantitative numerical data. So give a sequence of example state. The world is deciding based on competing. Okay. So other learning variants, semi-supervised learning, active learning, very active research of area, online and offline. Type of model. One is generative model and discriminative, that you learn once you learn about deep learning model. Parametrics and non-parametrics, this also I'm not going there. So now let us little bit understand about classification, prediction combined with supervised and unsupervised. Okay, when supervised, so that means label is there. Label could be your discrete label and continuous. That means +1 and -1. Then you can go for classification when you have continuous labels like 0.45, this one real number, then you can go for regression. If you have discrete labels and data is unsupervised, you can go for clustering. Otherwise, you can go for like face recognition and other. You have to go for dimension tree reduction, PCA, principal component analysis. Okay, this sort of things you can go. So little bit understand about K-mean algo. Okay. And before this, understand what machine learning algo is doing. Already I told we are learning one mathematical models. Okay, mathematical model is some equation. So my objective is like y equal to some function f and input is given x. So what is known in supervised learning? X is known, y is known. Only you have to learn this y. Based on this one, x and y is input. Okay, x and y input. Your model is learning this function f and you are predicting. Okay, that is what I'm expecting. So same thing is when I'm passing apple, it is giving apple label, this is tomato label, this is cow label. So this is my objective to find better this function. Okay. So this is what machine learning, y equal to fx plus c, x is input, y is your output level, f is your function which we have to learn. Okay. So training, given a training set of examples. So training, if I'm referring our x, it is not simple x. It is not scalar value. It is vector. X is n dimension. So you can write x equal to n dimension data or 2 dimension data. If you are getting real line, so I can write this. It is 2 dimension data. Y is binary classification. So y has element plus 1 and minus 1. Okay. So I can have this kind of notation which I can use for representation of this one. So we have training samples x1, x2, xn, and y1, y2 is label. So each data I have provided the x1 and y. So each xn is y1 data, and maybe x which is input is certain dimension, 3 dimension, 4 dimension, 2 dimension, and 100 dimension data is there. So during training, you are learning to learn this function f. F could be your any decision boundary, and f. And what is my main intake from this function f? So the function should, because initially you have x and you have y. Now, after applying function, you will get another y. So my objective should be y calculated minus y actual. This is my error. The difference should be very negligible, almost 0. Okay. I want difference between calculated and predicted error should be very less. Then only model will tell. No, otherwise no people will purchase your model because they have this problems. Okay. So given problems with the set of labels, so we have 51, we have another 1 hours. Okay. So given a training set of examples, x1, y1, x and y1, estimate the predictive function f to minimize the prediction error on the training sets. So it is not possible that if you have very minimum training error, you will have testing error also less. No, your testing error can increase also. Testing, what will happen? Already you have learned this function f. Now you have models. You have x. Now what you will do? You will provide just x. Model is there. You will get some output. Okay. And maybe if it is supervised learning, you might be knowing y before. So if difference is 0, then your model is perfectly fitted. If and we'll not check for only 1 or 2 or 100 sample. We'll check for 1,000 sample. You should predict correctly for almost every samples. Okay. Then we'll aggregate this combined error. If error is very minimum, I will go, let us say that this is okay. You go ahead. If it is difference is error is more, so what I will do, I will ask. No, you take more variety of data and you try to learn more like this. You can do. So testing, apply the function never before seen the test example. Then only you will have better testing. If you have seen already example before, and you are learning with the same. That means if I know that you are RAM and I'm testing, sorry, RAM is not perfect. I need to identify cow and dog. Okay, dog I have seen and cow I will find I'm not seen. Then in this case my prediction is okay. But if similar is same image I have seen before and I'm trying to predict that image, so I will predict like that. I've given you exam paper. Okay, you have learned every sort of things. That time you will predict very good. You will get a score 90. But what will happen if you have not seen the question paper and you have learned very nicely? In this case, you are performing 80-90% things. Then I will say that we have better generalization capability. Okay, so data should be unknown data when I'm going for testing. Same training data I cannot use for testing. So you have training array images, image features you will extract if you will go for image processing. So image features, textures, their dimensionality, diameter, all things. You will do training and you will provide training label also. This is during training phase. And then you have prepared models. This is learn model. Now testing, what is happening? I'm taking one image and I'm considering this learned model here. Those I require features also. Image feature I've extracted. I went through this learned model and it has predicted something. If it is close to my original prediction, then I will say that model has learned nicely. So if out of 10, 8 times I predicted correctly, I will say that 80% accuracy it is there. But accuracy is not always measure. You can have other measure also. You can go for confusion metrics like recall, precision, all. Because in case of unlabeled data, accuracy is bias measure. Accuracy will give you 99 or 100 because it will ignore less sample of data. Okay. So features, you can have different techniques. So I'm not going again raw features. You can raw pixels direct value if you consider the image. So image is what? It is pixels. So you will get some values. If it is RGB image, you have 3 print RGB. If it is grayscale, you will get just value between 0 to 255, any value. Okay. You can get histogram techniques and different sort of things. So I'm not going this way. So just understand one classification, those it is supervised learning, because I'm giving the label already. Okay. So classification in case of nearest neighbor, I will do, because label is provided. So new sample is coming. Which sample it will become, whether it is going for blue dots, blue square, or red dots. Okay. So suppose new sample is coming and I don't know whether it is belonging to this class. So I will calculate, simply you will measure the distance. So in nearest neighbor, what I'm doing, I'm seeing that I'm close to which data points or which class, whether I'm very close to red one or whether I'm very close to blue one. So what I will do, I will take 3 or 4 samples which is in my close proximity. I will calculate the distance and then majority will win. Okay. So I've calculated distance here. So it is, if you are considering only one neighbor, you can have odd number of neighbor you will consider, because in even number you will have 2 and 2. In this case, you will get suffer. So I've seen one neighbors and simply it is very close to blue dots. So in this case, what is happening? This sample is becoming blue. Okay. But is this prediction correct? Just considering one sample is okay? No. Maybe one sample is misclassification. So this time we have opted the option of like underfitting. I've taken one sample only. Maybe I need to test 2 or 3. Those this sample should belong to blue only, because this is also closer to this one. This is also closer. That is quite far. You will calculate equivalent distance, because this is vector xy. You take the distance. In this case, so all we need is a distance function for our input. No training required in this case. Okay, no training value. Find a decision boundary and linearly separable. This is what linear function y equal to mx plus, already I discussed. These are the classifiers: SVM, neural network, nebulous, Bayesian, logistic. You can explore all sort of things. Distributed Boltzmann machine, k nearest neighbors, which we can apply in machine learning. Which one is the best? Now I'm coming. The model will be best which have more generalization capabilities. So now maybe this is the things or last concept which I will discuss, generalization. Okay, so generalization is very important characteristics that what I want, and generalization you can understand the things. I've taught you quick sort 10 times. Okay, in exam I have given some merge sort algo. I ask you to predict, but you are getting exposure of quick sort and you are unable to solve the merge sort. In this case, that means you are highly biased toward the quick sort. You have a very less generalization because you have not explored. But something I have learned: quick sort, merge sort, insertion sort. Then I am going for some third, fourth kind of sorting. In this case, I have exposure of little bit different sorting technique. So I have some generalization capability. This time I will perform better. That means I have exposure of different algo. Okay, so that's why variety in the data is almost important. Okay, imagine the training set must be annotated with the correct answer. Already I told correct label is very important. If it is clutch, I should label it like clutch. If you give clutch to something different, light, any other wrong labels, so your prediction will be wrong. Okay. So consider a motorbike. So you are seeing that different portion of motorbike, tire and all sort of things. So what is happening? Your spectrum is moving from unsupervised to fully supervised. So what is happening? From less information to you are going for more information. Okay. So the moment you are going for more informatics, more complex model, your model is going for overfit. When you have less, your model is going for underfit. So what I will do, I will try to focus on weakly in between. So what is happening? Unsupervised to weakly supervised and fully supervised. Here just they are giving image. Okay, they have not annotated. Now here they have specified this is human being. Those there is some background also. These are the dogs and these are the cars. Okay, after that they are going for specific, very minute details, eyes, nose details. So my spectrum is moving from unsupervised to supervised fashion. Okay. So what generalization is there? So I've trained with the 10 sample of apple, 10 sample of this tomato, 10 sample of buffalo, dog, and the horse. Now during testing, I'm giving different kind of dog, buffalo, tomato, this apple. It should classify better. Okay, it should classify better. So here I'm giving variety, 4 or 5 variety of algo. Here I'm trying to see their performance. Okay, so how well does a learn model generalize from the data? It was trained on the new test data. The test data only we can see the performance. So many times you heard about people are telling, if you are not getting good performance, increase data. Okay, or variety data, take more samples. This is the things which I am telling, but more data will lead for overfitting. Okay. Now I'm coming main points which I was trying to explain generalization. So there is two terms is bias and variance, and already I explained, but again I'm going to explain same thing. So in prediction model, you have seen that might be I've fitted this simple line. Okay. So this data, this is error because my data point is there and the sample is far from distant. So in this case, this is we consider bias. Okay, bias is error from origin. This is my error. Okay, so you can take aggregate all errors. What will happen if you just take this distance, and sum of all this distance, positive and negative error will cancel out, and effectively your error will become 0, which I don't want. Okay, so what I can do, I can go for modulus error. Somewhere 10 is 5 minutes before, somewhere 10 is 4 minutes before, here 10 is 5 minutes late, and so on. So aggregate behavior you require. So you can take modulus also, but most of the times you heard about square root difference. Okay, mean square error. So the things is that because maybe some bias, some outliers is there, some unknown and unavoidable circumstance is coming, which is only one sample. It will shift my hypothesis here. So maybe it is good that you avoid this outliers. It is not like that in class one student is not understanding, I will not teach to other. I will keep teaching to that student till other have to wait. No. What you do, you will teach average kind of things. All students should learn. You will not only focus. If you focus only topper student, model will become overfitting. If you focusing only poor students, that is also not good. So you have to go for average. 60 or 70% of students are understanding, then I will. So bias is that how much the average models. Okay. So model is there. Suppose you have data points like this. Data points. So you can fit this model. You can put this model. You can fit this model. Any sort of model, you can go for higher or polynomial. So if you take the average of all model 1, 2, 3, okay? So how much average model over all training set differ from the true model? So training set, this is first time training example. Okay, first model I've considered for this one. Then I've taken another training samples. Okay, another training sample. This time same model is there. How far is prediction? Okay, so that is what bias. Bias is telling how far you are. This is bias from model. It is there. So how much the average model over all training set differ from the true models? So this is my true model outside, and this is my predicted model. So there is error. So my objective to minimize this error. So that is what bias. Bias is considered as error, and many times error is noise. Noise is also one factor for error. So when you are taking through sensors, so you are getting some noise also with the data. So removal of noise techniques is also there. But error here you understand because each data sample, which when I'm talking about data sample, is coming with some noise. If you have this data sample, this data sample, this data sample, it is coming with the noise because you have taken input through sensory organ. You can have some genuine noise, some environment factor also there. So if you map this data with a higher order of polynomial, what will happen? You are trying to map noise also. If you are fitting very basic model, this is also going for underfit. So let us take average model, which is not exactly matching this one model, and this much of error is acceptable. I will accept this much of error for generalization. If you have tuned this one and all the noise is in your model, your model will suffer with the overfitting. So now let us understand what is variance. So you have data samples. One model is this one, and the model you can fit like this, and the model is fit like this. It is only x square kind of function. If you have higher order polynomials, you will fit model again second time, so you will have much variance. 2 model, 3 model, all will have variance. So that is what variance term is that. So once you will go for higher order polynomial, you will have much variance. So how much model estimated from different training set, different procedures time. So first time I will use, suppose let us consider I am considering 9 order polynomial. So first time I fitted, second time I am fitting, third time. So you will see that first model, second model, third model will have high variance, because this is higher order polynomial. If it is line, you will have very less difference between first, second, third times. Okay. So how much model estimated from different training set differ from this one? So I need to do trade-off between bias and variance. So because we want generalization. Generalization will come when we have less bias and less variance. Okay. So underfitting model is too simple to represent all the reports. The moment I'm talking about underfitting, suppose as I was fitting the line, in this case you will have more bias, more error, but variance will less variance, because model is very simple. The moment you will go for complex model, you have mapped the noise also, so training error will be almost zero. Training error will be zero, but testing error will increase and variance will more. So first you understand, when I'm just fitting the line, you have 4 error, 1, 2, 3, 4. This is what bias. So more bias is there, variance is less, because another line if you map. So both line has very much similarity, not much difference. Okay. Now let us go for same data samples I'm concerned, and I'm fitting some complex model. Okay. Second model I'm fitting. Third model I'm fitting. All model are, so almost they are matching with the data points, so they have very less error. That means bias is very less, but variance is more. Okay, so that is what overfitting. Overfitting. Okay, so underfitting and overfitting, I think I hope it is clear. So in this case, underfitting, what is happening? Bias is getting high and variance is low. Okay, so what is the consequences if model is getting underfitting? You are suffering with high training error, and then obviously training error is more to testing error is more. That is okay, that I can accept. If I am not taught you well, you will not perform well in the exam. That is okay. But in case overfitting model is too complex and fit irrelevant characteristics, that is noise also fitting. So model will become complex and the things will become complex. So what will happen? You will have high variance and very less bias. Bias will become less and variance will increase. And it is the case that I taught you one algo 10 times and the exam another algo was asked. You are unable to solve because you are only focusing on one algo. You have not seen the characteristics of the generalization of another algo. So that is what problem you will face with the overfitting models. Okay. So what we'll do, so there are many techniques to avoid overfitting in the deep learning, like early stopping. Don't try to learn the overfitted model. Before getting overfitted, let us stop. So there is sweet region where I can stop. Second thing is that you can increase more variety of data. Like in image, if you are getting very less sample, you just rotate, give tilt and all sort of things. You add some noise also. You can add noise as input. You can add a noise as output. Because we know that always each data point is coming with a noise. So this is not good if you map these data points. So let us add some more noise and try to do this. Okay. So bias variance trade-off, you see that already I explained enough. You can fit line, you can fit curve, you can go for higher order polynomial also. So this model is suffering with the underfitting. In this case, second order, I have mapped all the noise, all data points. Error is getting reduced, but model is getting to suffer with overfitting. So model, in this case, we have very less parameter. In this case, we have very high number of parameter. How this is less number of parameter? This one, because here equation of line y equal to mx plus c. Only parameter m and c. In this case, y equal to 4x square. So yeah, in this case, you have 9 order polynomial. You will have 9 coefficients. So number of parameter is increasing. Obviously, your performance training error will be less, but testing error will be increased, and your model will become complex. And this is also, as a machine learning engineer, our job is that we have to reduce the complexity of model also. because we cannot make the complex model number of parameter it will increase. You have heard about also in deep learning, when you are moving from neural network to deep learning, it is suffering with the overfitting because number of parameters is increasing. So model with too many parameters are inaccurate because of large variance. Okay, that means they are quite sensitive toward the noise. So this derivation I will not go. You can refer the Wikipedia, and this generally we used to teach this during class notes. So this you can easily get. So how you can get? You just take the expected value of y actual minus y calculated. Okay, and the noise y equal to mx plus c, but this is not actual x. Okay, so your noise will be the initial data point. I'm considering x, it coming x plus c, y equal to mx plus c, and this x is what? It is coming with some noise. It is not original x. So this is x1 plus some epsilon. Epsilon, I'm considering the noise, epsilon noise. Okay, because all point is coming this one. Epsilon has normal distribution. You can consider that like zero mean. Okay, zero mean and 1 standard deviation. Okay, so you can have epsilon value because all data point is coming with noise. Then if you solve this one, take the expected value, you will get this derivation, very easy derivation. So what this derivation is telling, the mean square error, the expected value of mean square error is noise square plus bias square plus variance. Bias I explained, variance I have explained, and both are square. That's why you have seen that we are generally considering mean square error, that is square. Variance is there. Noise is unavoidable. So there's two different kind of noise. Noise are many times important also. Suppose you have to send someone face and no one can recognize it in between, you can add some noise so that no one can decode the things. So noise is also important property. Okay, but in this case, this noise is machine noise or environment which is almost unavoidable. Only I can deal with the bias and variance. Bias you can reduce how? By increasing the model complexity, and variance you can reduce by decreasing the model complexity. So the objective is that let us make the trade-off between bias and variance. So bias error is due to incorrect assumption due to simplifying model. Variance due to complex model. Okay, and due to variance, what will happen? You will suffer with the testing error, not n. So you can see this Bishop book, neural networks or machine learning, pattern recognition Bishop book also, they have given this derivation. Okay. So now let us understand how bias variance trade-off will lead for generalization. Okay. So when I'm moving from left to right, model complexity is increasing. Y-axis is showing the error. Okay, x-axis is showing model complexity. When your model is very simple, so left-hand corner you can see that what is happening, very high bias, very much error, and variance is less. In this case, we have low bias and high variance. Okay. So training error is almost initially you have the moment you have increased the complexity of model, so model got overfitted and training errors become almost negligible or zero. Okay, initially you have some error, but is going for almost become zero. Testing error, what is happening after this point? Testing error is going exponentially increasing. So models suffer with the overfitting. So what you can do, early stopping techniques you can apply. You can stop here. Okay, you can stop. This is okay. Training error is more okay. Testing error is okay. But what is happening? Training error is almost zero and testing error is going to increase. That means model will suffer with overfitting, and it is happening with the high variance. Low bias. Low bias is possible because you have mapped noise also, and variance is that you have complex model, you have number of parameter increase. If you use neural network with the 5 or 6 neurons with the 6 layers, your parameter will increase, number of weight and bias will increase. That is what hyperparameter. That's why hyperparameter estimation is also very important. So this is underfitting area, this is overfitting area. Underfitting, your training error is also more and testing error is also more. Overfitting, training error is almost negligible, zero, and testing error is more. So here we can stop somewhere. This much of training we want. So model will accept this one. So test errors, many training examples. So you can see that what is happening with the many training example. Your training example is going to test training error is going to be 0. But in this case, if you have very few training example, so this kind of curve you will have. Because very few curves, you cannot model higher order of polynomial there, because almost you see that if you have 2 data points, okay, you have 2 data points. What is the use of fitting? This curve will predict finally for you. Same data point, I can use 3 order of polynomials, like 4 order. So what will happen? This model will perform almost similar to this model, or maybe more drastically it will give poor performance. So model selection is also important. Which degree of model I will select? Okay, if training, generally if you have 10 samples, you cannot go for more than 10 degree of polynomials. Okay, maximum I'm talking about. So effect of training size. So how training size, number of training example I'm increasing from left to right. Okay, so what is happening? Training error is going to little bit increase, because if you have 2 samples, you have just identified Ramasyan, that is, at the moment you have to identify 100 people, so your training error will increase, but ultimately testing error will give down, and that is the justification why generally we used to say that if you are suffering with model prediction, just go for high training inputs. Okay. So this only with that number of training sample with the variety is leading for generalization. Okay. So very famous theorem, free lunch algo. Nothing is free. Everything you have to pay. If you are paying some, you are trying to become the model overfit, you have to pay with the testing error. If you are going for overfitted, underfitted model, you are suffering with training and testing error. So always every action is coming with some cost. Nothing is free. So free lunch algo is also there. So no classifier. Before this, let us understand, no classifier inherently better than any other. It depends on you, how you are training, how many parameter you are trying to do. Okay, any classifier can perform better if you can fine-tune parameter. If you can fine-tune your data set, you can label-based data. So you need to make assumption to generalize. So already I discussed about 3 error, which is here. Noise square plus bias square plus variance. Okay. So noise, one is inherent noise, which I cannot avoid, that is noise square. Bias I can do due to oversimplified model, and variance due to inability to perfectly estimated parameter for limited data. That is what variance is there. Okay, so complexity you are increasing, that's why. So how to reduce variance? So either you take less number of parameter, you can go for regularization. There is L1 regularization and L2 regularization, and get more training data. So a little bit discuss these 3 terms. So suppose my equation is y equal to mx plus c. Okay, this is my model. I have calculated something, or my actual model is 0. This is my actual output, and this is fitting. If it is almost 0, that means model is almost fitted. Okay, so that is there. But ideally we never expect 0 difference. If it is 0 difference, it might be suffer with the overfitting. So what I will do, I will add some cost function. Cost function, you can have mean square cost function, cross entropy cost function. I will add some regularizer, some add-in, because regularizer is working many times weight decay concept, like you can have L1 regularizer and L2 regularizer. Okay, so like I'm using neural network equation W transpose X plus by I've added what 1/2 input parameter W square modulus. This is your L2 norm. Okay, L1 norm is just take modulus. L2 norm I am taking this one. What will happen now? I have added this extra term. Okay, this is L2 regularizer. Okay, so square I have taken, so I can easily do differentiation also, and 2 to 2 will get cancelled out. It's just for adjustments. So what will happen? It will reduce your weight, and ideally you will never come across your actual and calculated. It will never become 0, almost 0. Okay, because this extra weight is given. And what is this extra weight? Same parameter which I had already. I have added extra weight parameter. I'm not adding some new parameter. I'm adding already weight. So in this case, what will happen? This extra weight is there, so ideally gap will become this way. So that's why L2 regularizer is considered. There is L1 regularizer and there is L2 regularizer. Okay, the L1 is regular modulus, L2 is least square. Okay, so this is also the technique to avoid the overfitting. Choose a simplified model, not very simple. If it is 9 order polynomial, you use 7 order polynomial and get more training example, which I already explained. So I will get more training example. Like suppose you have this digit recognition. Okay. Digit recognition, I will go for digit recognition. So you can augment the image also. Many times we don't have images. Like suppose, let us erase first this one, clear the screen, and this one. So I was coming on this point. What is how you can increase data points? How you will get for more training samples. So what you can do? Suppose this is my one. Okay. So you can rotate this one by 45 degrees. You can rotate in both directions. This is also one. Okay, one variety of thing. You can rotate reverse order so that you can get more variety of data and number of data you can increase when you have very limited data. Okay, so this is data augmentation techniques by which you can increase the data. So that is what bias variance trade-off. I will take some question if anyone has doubt on this one. So some classify k-mean, SVM boosted decision tree, and then you have neural network, Bayes, Bayesian, logistic regression, randomized forest, RBM, and Semwal learning are also very famous, where you can merge all the poor classifier. When all classifier is performing very poor, let us take the average of all, that is what ensemble learning. So decision tree as well as randomized forest is example of this one. Little bit you understand about generalization and discriminating classifier. Okay. So generalization and discriminating, I'm not going for this depth of discussion. So represent both the data and the labels. Already I discussed about so far generative models. Often make use of conditional labels like Bayesian probability, like Bayesian learning networks. If you have learned Bayes, you will have some. You have to update your belief, Bayesian belief, based on probability. Suppose the floor is wet. In this case, you will try to investigate why floor is wet. So you have seen that there was leakage in toilets, so that's why water is there. So you will tell, oh, with 100% probability, I can say that this is due to the leakage. But after some time, you have seen that someone has cleaned the room, so your probability belief will update with respect to time. You will tell, oh, no, 50% chance it is might be possible to leakage of tape from toilet, or 50% chance such and such person has cleaned the room. So like this belief network. So Bayesian networks and Bayes classifier. Model of data may apply for future prediction, correct? In discriminative models which have discriminative capabilities, plus minus, like learn to directly predict the label from data. So like logistic regression, SVM boosted. So little bit understand about k nearest neighbor, because this is clustering techniques. So I will see that how many k nearest neighbor within in my region, and I'm close to which particular class, then I will categorize my data into that. So you can see that two black dots, one is this one and one this one. So this is obviously you can see that two red and two green are near to this one. So which category it will see? If I'm seeing only one class neighbor, then it is the case of red and green. If I'm seeing two neighbors, then it is case of both are coming in green zone. Okay. So you can go for 3 neighbors, 4. So decision of size of neighbor is also important. So simply you can have a hit and try. So with infinite example, one nearest neighbor probably has error that is almost twice than Bayesian optimal error. Okay. So already I discussed a little bit to understand about support vector machine. So what support vector machine SVM is doing? Because so far all classifier was trying to classify data, but no one was trying to classify the decision boundary, which is separating both classes with the higher separabilities. In this case, SVM support, there is linear and non-linear SVM. In linear SVM, what is happening? It will try to separate linearly separable data Okay, how it will separate? It will try to find that hyperplane which can separate out both positive and negative class with equal distance. So these are the support vectors which are falling on the line, and the line is passing from in between. This is your decision boundary. Okay, in case of non-linearly separable data, first you try to project that data into higher dimension and then apply SVM. Okay, so now you can see that here easily you can draw the dots and data is red and blue is okay. But second case, what is happening? If you draw the dot here, these three are going to misclassify these three. If you are placing dot here, this one. So what I have done, I have projected data into this one, and you can easily draw the line. This is what kernel function is doing. Okay, SVM kernel function. So dimensionality, as I talk, and it was topic of my presentation also, dimensionality. Already I discussed what is dimensionality. Here it is two-dimensional data. This is labeled data because blue and this one, but this is non-linearly separable data because I require circle. Okay, to make it linearly separable data, because SVM will not work with the non-linear decision boundary. Though it will work non-linear SVM once I will apply on the once I will convert this data into high dimension plan x to 5x, x to 5x. Okay, so what I have applied some kernel function. I converted this 2D data into 3D data, and then I'm applying. So general idea, the original data space can always be mapped to some high dimension space. So this is like kernel function. It is like dot product x square, but it is actually dot product. Dot product is not complex because the moment you are going for x to x square, your complexity is increasing for n to n square. But dot product will remain the same level of complexity n. Okay. Yeah. Okay, so we'll not go in much depth. I will keep my presentation up to these points, and I will open my presentation for question answer. Okay, so let me see that if anything is missing which is required. Then if people are looking for ML projects, so you can go for different kind of projects in robotics also. Gate pattern identification, biometrics very widely using face recognition nowadays, deep face, emotion recognition, liveliness detection, robot path planning is used, data compression you can use, image compression you can use. Okay, so recognition patterns, facial identification, facial expression, handwriting, spoken words, speech recognition, you can go for HMM model, generative patterns, and we have probability kind of concepts. Okay. Sample application, web crawling, computational biology, finance, e-commerce, space exploration, robotics, information extraction, social network, and debugging. So with this, I will close my session. Okay, so I will open this for question answer. I will request to Vishal sir, can we have this for question answer? Yeah. So
thank you so much, sir. Thank you so much, sir, for the wonderful talk. And I hope everyone had a good experience while listening to you, and everyone had and it's my sheer belief that everyone was very quite entertained by the presentation which you just gave. Now I would like all the participants over here that if you want to ask any questions, any query if you have regarding the presentation which Dr. Semwal just gave, you can one by one raise your hands and I'll call out your names. Then you can unmute your mic one by one, and then you can please ask your questions. If you want, please raise your hands one by one. I guess no one. Okay, so no queries, anyone?
So they can write in chat box also if.
Yeah, if you have any queries, you can write in the message box as well. And if you don't, please raise your hand. You can. Dr. Semwal is here. You can quickly ask anything if you want. Okay, I guess no one has any queries, sir. So just before ending the ending this session, I would like to ask Mr. Gaurav Tripathi to share the YouTube link of the previous morning session. All the participants, I request you to, if you want to revisit the morning session, or if for some reason, if you have missed the session, you can watch this, the entire session on YouTube as well. So, okay, sir, Bhaskar sir, Khyati Srivastav is asking a question in the chat box. Application of ML with robotics specifically.
Okay, the application of let me see the question is here.
Application of machine learning with robotics specifically, sir.
So you can go for like as I discussed about supervised learning, unsupervised learning, reinforced learning. So most of the things, if you say that robot vision, in robot vision, deep learning is quietly explored nowadays. Almost many work has done because they should have some capability like human being. Robot required to like if you go for object recognition, they have to pick and place some objects. So that time also we are doing. So the important thing is that trajectory learning, where most people are going for this one, trajectory learning. Suppose robot has to learn the walking. In this case, what we will do, we'll take the data for human being and same data will apply on the model. For this, we have to design the models. So you can apply trajectory generation, robot path planning, even many AI algo we are using for when mobile robots are walking. Okay, to avoid the obstacle. Object recognition. Okay, so this is the part. Even speech, nowadays speech is there where robot has to imitate the human being or they have to reply like this is Google also has this one, Microsoft I think that. Okay, Nexa, so they are also replying our queries. So robot is full of opportunity in robotics ML. Almost every sectors, whether it is planning, is it vision, you can go for speech recognition, you can go any specific domain, then also I can tell the answer which specific robotics query you are asking.
Thank you, sir. So, Khyati, I would like to add something to what sir said. Sir specializes in robotics. Sir has worked extensively in the field of robotics. So, if you have any questions, you can contact Dr. Semwal personally as well. He has shared his email ID with us, and we'll share his email ID if you want. So you can reach out to him for any possible queries or any collaborations if you want. So apart from that, I think we had a great session. The link for the morning session was just shared by Mr. Gaurav Tripathi over here. And the link for this session will be shared tomorrow maybe. And we will additionally at the end of the workshop, we shall share all the link for all the sessions. So thank you everyone for joining us. Thank you Bhaskar sir for giving us this wonderful session, and I hope to connect with you real soon in the upcoming events which we are planning to organize. And thank you so much, sir.
Okay, thank you sir. Thank you lots.
So okay, participants, to all the participants, we shall meet tomorrow at 10 o'clock. Please try to log in just before a few minutes before the start of the session, so that it is easier for us to start the session on time. Thank you so much. Thank you so much.